let's start with a question, okay? What is Node.js, okay? And of course, we are going to ask to ChatGPT, okay? Because as all good programmers now, we all ask everything to our AI overlord, and we ask what's Node.js. And the ChatGPT responds in a very, very good way, saying that it's now it's not saying anymore that is single-threaded, but 5 minutes ago it said that. Okay, good, it improved. Okay, frankly, I had the slide ready. Okay, this is a very good one, and it says it fixed itself. Okay, after I poked it too much. Anyhow, so ChatGPT not so long ago, it was saying that Node.js was single-threaded, and it's not. Okay, it's not anymore. And this talk is about how Node.js can be multi-threaded, and how can you exploit multi-threading in Node.js. So let's start. A few words about myself. I am the co-founder and CTO of a startup called Platformatic. Check us out, platformatic.dev. I am the Node.js technical. I'm part of the Node.js technical steering committee, and also a board member of the OpenTeams Foundation. Created a lot of libraries. Yeah. More importantly, though, you are using my software if you want or not. With I don't know, it's not 12, it's 30 billion downloads in 2024, something like some absurd number like that. Anyhow, let's get into Node.js is no longer single-threaded. Okay. Multi-threading in Node was first developed by Anna Ensingen with implementing the worker threads module. Okay. And in fact, there is a talk from 2018 called Node.js as Threads. Node.js, the Road to Workers, proposed by Anna. And this is a pretty good talk. Go and watch it. It explains a lot of things about how those were designed, what was the path to them, and so on and so forth. Pretty good. Okay. Now, this was supported originally starting from Node 10.5.0, and now we are at Node 22. So this is actually a lot, okay? It is a lot of past. Now, some important thing to know is each thread has its own independent event loop, and this is crucial to offload CPU-intensive tasks out of the main thread. Okay, so how does it work? Well, first of all, you need to know that in order to if you want to have two threads communicate to each other, okay, you need to use a message port. Okay, a message port is essentially it's something where you send messages to and can receive messages from. Okay, typically they are created in pairs via the message channel API. Basically, take a message channel, you get two ports, you send one to the person, the worker you want to communicate with, and then you can communicate with each other. How does it work? Well, let's talk a little bit. Let's show you. Okay. So the first thing that you can see is that you can create your worker, okay, in your main thread, and then in the worker you can call the worker post message ping, okay, which emits a message event on the worker thread, okay. And in the worker thread, then you can send it back a pong, which comes back as an on message event on the main thread. Very simple. You know, you post message, you pass message things back and forth. Okay. The semantic of those is by copy. So you send a message and it's copied over. You can also, there's also another thing called the broadcast channel API, which sends a message to all workers. Okay, useful? Yeah, useful probably. See, starting from Node.js 22.5.0, is we also have a new API called post message to thread, which allows you to send a message to a specific individual thread that you know, which of the ID you know. Okay, pretty cool. Now, this sends messaging. Okay, however, to have communication, you need really to be bidirectional and really not, you know, precise. Okay, you cannot really rely on you know, on a bad communication line. So the problem is that we need, what you need between two threads, in fact, is not sending messages back and forth, but is more or less implementing some sort of remote procedure call or RPC that you can have. And unfortunately, the event emitter API from Node is not really suitable for that. So we need to combine it with promises and a bunch of other things to make it reliable. Let me show you how. Okay. The key part is we create a new, every one time we want to create a request, send a request through, we create a unique identifier for that request, and then we create a promise with a resolve method to get the result. How does it work? Well, you maintain a pending object with the message ID. Okay. So in the server, when you receive a message, you respond. You call it this way. So first of all, you create a request and then you process it here. Basically, you use an ID. That's it. Okay. Is this easy? Is it this easy? Well, not really, because not all objects can be transferred. Okay. Only some kind of objects are transferable, and you can Google these on MDN or anything. You can find these things, and the suitable objects can be cloned using the structured clone algorithm, which you can find online and so on. But it means that the object is copied over, like there's nothing left. So this means that if you want to send an HTTP request or anything that is mapped to a low-level resource, so for example, like a socket, it's not going to be moved over. This is bad, okay? As I said, some objects are transferable, okay? And only some of them can be moved. So for example, a few objects that can be moved between threads are, of course, message parts. So I can send a message part over a message port. I can move the crypto key, for example. I can move a file handle. And I can move, for example, a web stream. This is pretty cool. I can move a web stream. Oh, wow, this is nice. Okay. There are a few other objects that can be moved, but some of them can't. So, okay. Pretty nice, right? Well, are you ready for more? Well, yes, because this talk is 1 hour. So, you know, got to be ready. Okay. So, we have talked about doing RPC communication, okay? But RPC is definitely not enough, okay? Typically, what you want to use worker threads, okay, is you have CPU-intensive operation that you want to tackle, okay? And in order to do that, the easiest way is to use a library called Piscina that was written by James Nell, Anna Ensing, and myself, and a bunch of others a lot of years ago. By the way, Piscina means pool in Italian. So that's the reason, from thread pool and so on and so forth. Okay, it uses all the cores available, so it's pretty performant, and everything is managed by the queue itself. So you don't need to spin up the worker, manage the queue, assign the jobs, and so on and so forth. Pretty nice. How do you use Piscina? Very easy. You just specify, give it a URL. Okay. Then you call piscina.run, passing in the message, and that translates a message in the worker thread. That's it. That's it. Nothing else. So there was a lot of more complexity with the RPC. Now all of this is gone. Everything is handled automatically inside of Piscina for you. So you have now gathered the capability of taking something that is expensive and moving it to a thread pool. Okay. But are we done? Okay. Is there anything more? Can we do more? Well, I don't know if you know, but there is something that you can use threads for that you probably couldn't expect it. Okay. Um, it's something that probably most people will not think it's possible. It's possible in Node, okay, but it's definitely possible using worker threads, okay. And a few people have tackled with this utility to do this thing. So you show my take. But essentially, it's something that a lot of people said it could not be done. It's possible using worker threads. Okay. So what you can do with worker threads is you can use worker threads to invoke an async function, okay, synchronously. And the question is, how can a promise be invoked synchronously? Because a promise always schedules something on the microtick task, on the microtick queue. So you can't do a promise asynchronously, but with worker threads, you can. Okay, you can transform any synchronous task in any asynchronous task in synchronous by running it in a separate thread and waiting for the result, right? So what you can do is using this library called everything, and it's a tiny utility that exposes an asynchronous API via worker thread. Okay, basically you create what it needs a shared array buffer. Shared array buffer are these magical buffer entities that are shared between two threads, so you can be write on one thread, read from the other, essentially. So the data between for them is shared. They also have some nice properties. You can lock them, you can notify them. It's a lot of things that can be done using the atomics module. And this library that I've written is called everything. It makes that synchronous. Okay, so essentially you can call the API exposed by the other library in a synchronous way, even if it's totally asynchronous. How does it work? Okay. Well, all of what you need is call this wire method and just pass the thing that you need to expose and keep the event loop alive. Pretty cool. Well, how is it done? First of all, we need to have growable async shared array buffers. Okay, growable shared array buffers allow us to essentially store messages of any size in it. We need to specify some metadata to start, then the length of the payload, and then the payload itself. And then we can use this module on one side called this function called atomics wait async on one side to synchronize with the worker thread in the media part. And so wait async and wait. It's fantastic. Okay. So first of all, in order to read and write on the shared array buffer, we need to do this a little bit of dance magical, few object offsets and so on and so forth. Fine. Okay. And this is the most important part. In order to pass the object through, we use the serialize and deserialize method from Node v8. This writes down a binary format of the object similar to what structured clone does, but you can invoke it yourself and it returns some buffer data. And then we deserialize the thing. Cool. Now, how do we call the method on the worker thread? So this is the main thread. And with the main thread, we call, we write the request, okay? We store and notify the worker thread, and then we wait the response, and then we tell the other thread that we have processed the response. Pretty amazing. Yeah. To receive the request, we need to use a while true loop that calls wait async. And wait async is a promise, can be a promise. So when we get a message, we do all those things, essentially. We read the data, we call the function, we write the response, and we notify the other side that that's completed. Yep. So why all of this is useful, and why it's being it's being done in this way? It's it's been done in this way. It's well, I started tackling with that technique to implement Pino and to handle the process on exit problem. So when you exit your Node.js process, you really, 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 really need to do some asynchronous processing to send out your logs, for example, but synchronously because your process is dying. So you can't do anything that is async there. It must be sync. So how do you make it something async sync? Well, you use this technique. It's also something that allowed us to ultimately supporting require ESM, which it's amazing to see. Okay. It allowed us what you call loader hooks like TSX and those kind of things, okay, to exist in combination with require ESM. So in other terms, if you want to do any asynchronous loading, you can not just internally use a variation of this technique to synchronize between threads and make sure that something synchronous like require ESM can execute asynchronous stuff like loading code remotely, for example. Pretty neat. Now, of course, we are not done, okay? Because, otherwise the talk would be way too short, okay? So let me talk a little bit about VAT, something that we released not so long ago. VAT is the Node.js application server, okay? Okay. And yep. Yep. So there will be, I will share the slide afterwards, okay? The slide will be there afterwards. So what does VAT do? VAT does, I can go back on the code, okay, if you want me to explain it step by step, okay? So we have time, okay? So this is what is happening, okay? So as I said, okay, so this is everything, okay, in the code. Okay, so first of all, we want to expose a synchronous API via worker thread synchronously. So first of all, we have the shared array buffer, so we create the shared array buffer. Then we create the worker thread, okay, here, passing in said buffer. So that buffer goes in data. Okay, and we specify our worker, which is our echo.mjs file. Then we call the make sync on the buffer. After that, magically, API, the object returned by make sync, have access to all the method exposed by this other file. How? Well, these are the method. Like this is an async function called echo, which is used on the other side. Okay, and how it's done is we collect the worker data, okay? We take the buffer in the worker data and we pass it to this wire method, which set it all up. Okay, so pretty good. How does it work? Okay, well, it works using the shared array buffer, and if it's growable, latest version of Node have this growable, so you can add more data to it to basically to not have any payload size limitation. And you can use APIs like Atomics Wait Async to configure this thing. How does it work? Well, first of all, to write on those objects, we write the so let's look at the write. Okay, first of all, we write the size of the buffer we want to write, and then we write the buffer. Okay, to read, we read the size of the data that we want to read, and then we read the data. Then we use the V8 serialize and deserialize method to get a binary representation of said data. Pretty neat. Okay. Then if we want to call a method, if we want to call a function, okay, and I'm overseeing simplifying this, first of all, you need to send that message. So you call the write method that we said before, you write it on the data, Okay, here we send the message. Then we store the results. So then we store, we call this, we modify the metadata to communicate to the other side, the other thread that is done, okay? And then we wait for a response. Atomics.wait is synchronous, okay? So the main thread blocks here until the worker has finished. Now the worker progress, okay? And on the other side, so on the other side, it calls atomic wait async. Atomic wait async is returns a promise, well, returns an object with a promise in it, whatever, that will resolve when there is some new value. And this is where it is. We get some value. If we add some value, okay, we can read the data from our buffer and then send the data back. So we have read the data, then we invoke the function, okay, and then we send back the result. Okay, we use this in Pinot. Hopefully in the code, I went to the code in a slower way, okay, this time, and here it is, okay. We get to the Pinot, as I said before, because on exit, it's the only way we can flash the logs, for example, to our external destination asynchronously. So you don't want to, so you don't lose any messages. And also this mechanism is what it powers features like require ESM or strip types, the TypeScript support for Node. Okay. So going back, are we done? Okay. This was so complex. Okay. It's so complex to deal with threads. Okay. And it's something that you can spend a lot of time with. A lot of JavaScript developers don't really know how to do multi-threading. And this is a tough subject. Okay, so how can you deal with it? Is this an easy way to deal with it? Or in other terms, can you easily multi-thread, for example, Next.js server-side rendering or some other very hard things? Let me show you. Okay. Last September, we launched something called VAT, the Node.js application server. And essentially that allow you to run multiple Node.js application we call them services within the same node process as multi-threaded application, and they can even communicate between each other. Pretty neat. How does it work? Well, it's that abstracts away all tasks like monitoring, logging, and tracing. It set it up for you automatically. And it also allows you to run multiple Node.js servers, as I said. And they are isolated because they run in each separate threads. You need to specify some config, tell it to essentially autoload your data and so on and so forth is a single JavaScript configuration file. Okay, and then you need something also for each service. Sorry, of course you need a package JSON, okay, for your service, and then just tell it it's just a basic Node app. In case we can also use Next or other things and have it different kind of application. Pretty cool. Now we can write a service so that we can write a service, but then how can they communicate with each other? Well, each one of them, each service is reachable by other services by just using fetch. It just works out of the box, so you can just do a fetch call. Will work. Pretty neat, and it's handled automatically internally without any port, no IPs, no nothing to expose. It's essentially a little bit of a mesh network in thread. And how do you create a service? Well, you can just create a function, okay, that return an app, and that would just set it up correctly and work. Now, I have a little bit more thing to show. That also supports multi-threading natively. So you have, imagine that you want to have 4 workers for Next.js rendering, essentially to avoid the event loop blocking on each one of them, so you can spread the load, okay, and use a lot more of your resources, okay? Well, you can do that with one config change. And this is actually very critical, especially for server-side rendered apps or other systems that are CPU intensive, to be able to do this immediately. So you don't need to handle Pishina or create stuff with that, because you can't really server-side render on Pishina, unfortunately. So time for the demo gods. Okay, where is it? And here we go. Okay, so this is my this is an example VAT application. We have our composer, a Fastify, a Next.js, and a Node app. Let's start with the Node app. The Node app is essentially a Node application that creates a server, calls listen, the port doesn't matter, and it does it responds with a JSON incrementing a counter. The Fastify application, similar, but we use the build function pattern. So by using this pattern, we show that we don't need to call listen at all. And this is actually a OpenAPI application because it uses Swagger. And then we have a platformatic composer. Platformatic composer compose the three services. So we have Next, Node, and Fastify. The composer is more or less like something like a little bit of an API gateway, something like that. So we can do npm start, and npm start, you see start Fastify. Oh, sorry, it's what? Sorry, okay, let's do that then. Okay, so we have the starting Fastify, starting Next, Next started, starting Node, Node that started, and then ultimately it's the composer. Okay, and yep, I need this thing to be not here. Sorry. And I need it here. Okay. Here we go. So here you can see that we have three apps, and this is, for example, a Next app. Okay. And this is the two services and running. Okay. Let's take a look at that app. Okay. Here we go. And nope, this is the wrong one. Okay. Here we go. Okay. So let's take a look at that app. Okay. So in that app, we can see that there is a Next app. And this is my page. Now this page is just two fetch calls, one to node.plt.local, the other one to fastify.plt.local. That's it. That's what it does. Okay, cool. So we can see it here. If I refresh, they both increment, pretty good. Our two counters are good, and so on. Nice, good. So how does this perform? Okay. So let's say we start an htop here, and then we do an autocannon, okay, with 100 connection, okay. And as you can see, this goes to 237 CPU. Well, we have, I don't know, 4 services running and so on. Is pretty cool, to be honest. And we get, I don't know, 134 millisecond, whatever, as response time. And more or less, I don't know, close to 1,000 requests per second, something like that. Okay. Now we can modify this guy and add the amount of work as we want. Okay. You can see that I have a lot of cores on my system, so I can do that. Okay. And I want to restart this thing. Okay. And now you see we have started 2 services for each. Okay. And here it says that we have started worker 0, worker 1, and so on and so forth. Okay. Cool. And now we can run our load testing again. And now you can see that the CPU has moved to 430% or something immediately, because we have essentially doubled the amount of cores that we are using. And now you can see that we have increased the number of requests per second by a significant margin, and also the latency has gone down, way down. Okay, which is a good sign, because it means that we have probably a lot of spare capacity. If we run it again, we can see this happening. That is actually using a lot of the thread capability of my MacBook right now. So it's I would say pretty cool, and it just works. So you can do Next.js server-side rendering, multi-threaded in a pinch. So I really like this, to be honest. It's it provides very well a much better way of running Next than other stuff. So this is that. Okay, here we go. Okay, slideshow. Okay, so this is it. I have time for I've a lot of time for questions. So what's up? I will share the slide deck with all of you afterwards. So Inessa, if you can ping me, I'll share the slide, the thing, the slides afterwards.
Sounds good. Thank you, Matteo. That was a great demo. And let me know if my sound starts breaking out, okay?
Sure.
Since my video is on. We have two questions. I'll go with the first one from Satya Rajagopal. I have a Spring Boot service that leverages Apache FOP to generate PDFs from XML and XSL templates. I'm considering rewriting it in Node.js. Given the significant server-side rendering involved, would Node.js be a suitable choice, or would it be better to implement this in Java, Python, or Go? My concern is that while Node.js is widely recognized for handling IO-intensive applications, Python and Java are often preferred for CPU-intensive tasks.
Okay. First of all, everything benchmark. Okay, take a look, do a little bit of a POC, verify if the rendering is fast enough. Typically, Python is not good for performance intensive tasks, unfortunately. Okay, it's good for a lot of other things. It's good because it has a massive and mathematical library that you can use for doing a lot of science experiments and so on and so forth. It's not fast. Okay, in fact, all the benchmark that you can find between Python and V8 and Python and Node.js is typically Node.js comes out better than that. Okay, so this is the first point. The second point is this is the talk right for you. Okay, so you have you want to build a PDF service, you can build that in Node, but you should do that using Pishina or something similar to Pishina. Okay, so essentially, if you have a service building a worker if you have a service to render that PDF, you need to render it in a separate thread. You need to render it in so that you don't block your HTTP, REST, whatever API or main render. Otherwise, it can be saturated very quickly, and you will end up with problems. Now, the same is true for other languages and libraries and so on and so forth, but in Node, you need to handle it in a little bit more explicit way compared to other systems. So I would say it's actually paramount that you use something like Pishina to do that. If you use something like Pishina, there's absolutely no problem in doing it in Node. Also, frankly, I almost never rewrite software that works. So if something works, and if you don't need to touch it, if you don't need to do rewrite it for business reasons, I would probably not rewrite software. Okay, software is good to become legacy. Okay, and don't want to touch it anymore or something. I don't know. This is the big rewrite never kind of happens. So yeah, that's my point on the topic. Hopefully, I answered all the bits.
And Satya, you can use audio if you're comfortable to ask your follow-up questions. All right. So Matteo, let me see. So Satya is asking, how can I use audio? Well, we need to give you. All right. Maybe you don't have permissions. I I apologize again. This is a new feature from Zoom that we're using and we're learning as we go. So a follow-up question from Satya for you, Matteo. HighChart's Node export server is a popular example of open source Node.js code using worker threads. I have used it personally. Do you have any suggestions on that? Can that pattern be used?
Sorry, repeat. I can't find the question, so can you paste it? Sorry, you were very fast.
Okay. And these questions are posted in the Q&A, which is a...
Oh, okay. So this is the Q&A question. Sorry, I need to read them because otherwise I have. Okay.
There are
So
two questions in the general chat as well, Anessa. I think it's maybe where Matteo.
okay. Okay. Yep. Sorry, I'm sharing the questions. Sorry, guys, if you so that everybody can see them. Anyway. Okay. High chart. Do you want me answer the high chart question, right?
Correct.
Okay. So this is where I answered. Okay. Then iChart notes is a popular example. Okay. I have never used iChart's node export server, frankly. So I don't know what this is. I can look into it. Let me take it. Here we go. Okay. Yeah. Let me see. Okay. Init pool. Pool. Let's see what how it does it. Oh, no, this thing uses something completely different, I would say. This is not using worker threads directly. It's using Puppeteer, I think. So I don't think it's using that approach. So no, it's not what I'm talking about here. At least this is what I am understanding by looking at this code. Oh, it's Tarn. Wait a second. No, maybe not. What is Tarn? So I'm doing scavenging. Okay. No, it's using Puppeteer and so on. This is not worker thread based. I have a rough feeling. No, I know exactly no. This is not worker thread based. So okay, done that. Okay, let me thank you. This is done. Yeah, it has used Puppeteer. Yeah, okay. I hope I answered that question. Okay. There's a question here. I'm not from a Java world, but I've heard people create a thread pool of 2,000 or so threads in Node, but we have one thread per core. How do we compare the thread, the performance here? Sorry, I don't really understand the question. What do you mean you have one thread per core? And how do you compare the performance? I don't understand this question. Okay. I can show you how to use Next.js Express later. I want to see. Okay, in your demo, we created one worker thread per core. In my demo, I created 2 threads for each services. So each thread had 2 services. So at the top, we were using, I think, 8 threads, okay, plus 9 with the top one. In reality, it was using, I don't know, 4 cores more or less on my machine. So you can, if you use multiple threads, even if you have less cores than the threads that are available, you are benefiting from you're benefiting from it, because that thread will not it's less likely to block the event loop, because the other one will still be kind of available. Okay, so it's and also you can spin up a separate thread while the previous one is dying or closing or erroring. So if one becomes unresponsive, you can very quickly spin up a second one, and that does it automatically for you. Spin up a second one underneath without you even watching. So yeah, that's what it is. It's I agree that there is no point in having lots of threads. Having 2,000 threads will be absolutely an overkill, but you can use way better the resource that you have available by having more than one thread. Okay, and because otherwise you can, as I said, you will end up in some situations where the event loop will be blocked or other things will happen, and especially if you have more than one core available for that specific process, essentially. No, cool. So Satya responds that highlights Node export server use Phantom.js worker thread earlier. Okay, Phantom pool. Use the worker thread. Okay, yeah. Phantom.js, yes, but it's not using the Node core worker threads. Okay, this is what I'm trying to say. It doesn't use so on. Okay, cool. Let me finish doing a little bit of an example using Express next. So let's say, okay, so here where did it? Oh, gosh, here we go. So this is our application we had before. Let me go back here. Let me stop it. Okay. Let's say you have your Next.js, your Express app. We want to add another app on Express. Okay. So let's create a folder here. Let's create Express. Okay. We need a package JSON. Well, yeah. Okay. Okay. Yeah, it didn't go here. Why didn't go here? Because it's okay. I need to call it something different. Sorry, my bad. Okay. Yep. Okay. Okay. Good. Now we have added Express. Okay. Now we need that JSON config. So we can exactly copy this one. Okay. And here we need a server.mjs file. So we can import express from express and create an express app like this. You can do this same pattern that we had before. We can even do this. So you can do app.get hello world, app.listen. This doesn't matter. We'll expose it in another way. Yep. Okay. And this is app dot. I don't remember. Let's do this. Okay. Cool. This is an express app. Now we can just go in the composer and expose this. You don't need the composer. It's because we have more than one app on the same topic. Okay. And we are exposing express and we are exposing express. Okay. Now we can go back in here. We can start this. And if we can go back, as you see in the slides, now we have also express. And if we open up, this is the hello world that we have just added. Takes literally like no time to do this. A few bonus features that we do have, okay, is, for example, if you start this automatically, you automatically have support for OpenTelemetry, Prometheus. So you get it exposed on port 9090. So you can do 9090 metrics and you get all the data for all of the workers. Okay. And HTTP requests, HTTP GGC durations, you get all the data that you need. Okay. Pretty cool. And you can even control it. So, for example, you can see that we have where are exposed, what are the directory. You can see we have a bunch of comments here. So hello, and you can get the services. You can start, reboot, blah 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 blah. So do a bunch of things. Yeah, I hope I showed the questions that were being asked. Is there anything more? Oh, there's a few questions. Can you recommend a library that can be used for understanding Node.js application performance, internal event loop, a blocking function, something like Dynatrace, but gives node-specific metrics? So you take that, so two bits, okay? You take you can take that output that I showed, this thing that I showed here with curl, okay? This is Prometheus metadata data. So you take something like the Prometheus agent and Grafana, and it collects it, and you pipe it there, and then you can plot those data from very easily. Okay. You will see the event loop. You see the event loop and so on and so forth. You don't see the blocking functions. You don't see the blocking functions, but you can see all the other bits. If you want something that like Dynatrace but gives no specific metrics, well, that's our commercial product. So we got to make money somehow. So you can take a look at that. There are others kind of products like that give you this kind of information, but it's we do. So you can check it out. I talked about all of this is open source, but if you want specific dashboards and so on, is all part of our commercial offering. Okay, this one, we covered this one. In your demo, you were showing the performance stats. Can I get some details on that? How can set up of any my Node.js project that use multi-threading? Okay, so what I showed you here is I use something called autocannon. This is autocannon and to get the information. Or I use these metrics that are the data for my services. This is something that you can use. You can set it up. You just need to use, as I said, Prometheus. The Prometheus agent in Kubernetes, for example, will come and rip this data out and then forward it to Grafana for rendering. So I am stay tuned on my socials, because very soon, okay, we're going to announce something new on this topic that will be open source. So stay tuned, because that will be pretty cool. Let me see if there is anything more.
We have one question from Tosh Boszkowski in the Q&A.
Okay. Okay. In the example you provide, meaningful on a production environment Kubernetes instead of multiple thread, you would instead have multiple pods. Well, it's slightly different. Okay. Okay. Imagine in this way. Okay. You have in a when you're building a system, you can scale them up or down, either horizontally or vertically. Okay. If you spin up multiple threads of the same thing, okay, you spin them up vertically on the same pod. Now, why would you want to do that? You will want to do that to avoid situations where the load balancer is playing against you, okay? Especially with a lot of load balancers are very stupid, okay? And, they implement something like round robin, okay? Now, something like round robin is not a good load balancing algorithm most of the time, because it does not route it to the server that is free. It just routes it to the server that's next in line. Okay. And it's based on the concept that all requests are essentially equal to serve. But if some requests are heavier to serve, more or less, Murphy's laws will tell you that we'll all end up on the same server. So these allows you to provide slightly bigger servers and reduce the number of pods you have, and your load balancer will essentially perform better depending on your depending if you have this kind of load. Now, the other use of something like that is that imagine that you have, I don't know, 20 microservices, okay? If you have 20 microservices in your system, you can deploy multiple of them inside the same, as multi-threads in the same pod, okay? And by doing that, you can actually massively simplify your deployments for those, okay? Because if you do, because then you essentially, especially if you have built them as a distributed monolith, as it is very often the case. So it provides a good alternative for that. That pattern is actually how a lot of Google system have been built. There is a paper from Google that explains how they're doing this, and more or less they're following this pattern or a very similar edition of that of this pattern in their system. I think they're doing it with C++ and stuff like that, but it doesn't really matter. But they just basically bundle all the microservices together and just run them as a big monolith as on their systems. So.
Matteo, I know we're at time, so I will ask you just one more question that was asked in the chat early into your presentation.
Okay.
And here goes. Is it a good approach to use worker in a logger? For example, assume I want to log my API request, but I don't want to interrupt the main thread and increase performance.
Yes, that's how Pinot works. Use Pinot. It's literally how Pinot works. So you can, if you go inside Get Pinot, you have these transports, and each transports are being run on separate threads. Okay, so it's all explained here, but basically each one of them is run on a different thread. And here you can specify multiple targets, so you can have a remote system running where you log against.
Thank you so much, Matteo.